Hello everybody and welcome back to another episode of Math with Mr. Emond. Today we're going to be continuing on in our unit on absolute value and reciprocal functions. We're in section 7.4 looking at reciprocal functions, and this is video 2 of that, and we are looking specifically at graphing linear reciprocal functions. So the first example we're going to look at is graphing the reciprocal of a linear function, and we're asked to consider this original function of f of x, negative 3x plus 4. And we're first looking for part A, determining its reciprocal function. So remember, a reciprocal function is written in this form, g of x equals 1 over f of x. Or in our case, our g of x is going to be equal to 1 over f of x, which is negative 3x plus 4. So here is our reciprocal function. F of x is negative 3x plus 4, so you just input that. Determine the equation of the vertical asymptote of the reciprocal function. All right, so I know that the vertical asymptotes happen at our non-permissible values of our reciprocal function. So what are my non-permissible values of g of x? Well, my non-permissible values, remember I'm going to set this equal to 0. So negative 3x plus 4 cannot equal 0. And we're going to isolate x. So negative 3x cannot equal negative 4. And then x cannot equal negative 4 divided by negative 3, which means my non-permissible values are 4/3. Okay. So this actually becomes my vertical asymptote. So I have a vertical asymptote at x equals 4/3. My non-permissible values are my vertical asymptotes. So let's go ahead and kind of graph this in now. So we're going to go and take a line. I'm going to make it green and it'll be a dashed line. And we want to find x equals 4/3. So that's 1 1/3. Which is about there. Okay, so there's my vertical asymptote, and I'm going to go ahead and label it as such. Okay, now we're going to graph the function f of x and g of x. So f of x we can do in red, and f of x was just a line. It's negative 3x plus 4. So that has a y-intercept of 4, which is there, and it has a slope of negative 3. So down 3 over 1. Down 3 over 1. Down 3 over 1, down 3 over 1. Up 3, left 1, up 3, left 1. Okay, that's probably enough points. Let's go ahead and make a line now. So we're going to make a red line. And we can go through this point here and try to line it up. That looks pretty good. Okay, so there's my f of x. Let's go ahead and label that. This is f of x. Okay, now we're going to have to graph our reciprocal function. So there's a few ways that you could do this. You could make a table of values. Okay, so you'll want your x values. You'll want your y values for the function negative 3x plus 4. And you'll also want your y values for the reciprocal function. Okay, so you could make a table of values. Try to pick points that kind of make sense. So I would recommend on this one points like negative 2, negative 1, probably negative 1/2, negative 1/4, and then 0. You want to have fractions, right? 1/2, 1, and 2. So it might be ones like that. And then you would just plug them into your equations and see what the y values are. The faster way of doing this is using your knowledge of how reciprocal functions are going to look. So I know that I have another asymptote, right? I have another horizontal asymptote right here at y equals 0. And I know that my equations, my function, when I graph it, it's either going to look like this. Let's make that smaller. It's either going to look like this, right? Or it might be down here, or it might be there or there, right? It's going to have this kind of a pattern. And the question really becomes, what quadrant will it be in? So what I like to do is I look at my vertical asymptote, and it's 4/3, right? And so what's going to happen when y is equal to 1? Well, that's going to be my invariant point, right? Is there, and then this is my other invariant point. So those are always going to be true. When y equals 1 and when y equals -1 of your f of x, those are invariant points. So now I know it's in these quadrants, right? And what's going to happen as we get, let's look at this point here. So this is y equals 4. What's the reciprocal of 4? It's 1/4. So that's going to be this point. This was 6. So at -1, our y value for f of x was 6. What's the reciprocal of 6? It's 1/6. So that'll be looking like that. This was 10. So this will be 1/10, right? So you can just kind of look at the previous one and do those reciprocals. What's the reciprocal of 1? It's 1, right? That's why I knew it was an invariant point. Now, what's going to happen when I do the reciprocal of like 1/2 here? That's going to be 2, right? 1/4 there, that's going to be 4. And so you can kind of see what's happening is we're going to be above the x-axis. We're in quadrant 2. And it's going to basically approach 0, right? It's going to get super small. And then it's going to run through these points and then get really big. So it's going to have a steep rise up to infinity. And it'll look something like that. And we can do the same thing here, right? What is the reciprocal of -2? Well, that's -1/2. Reciprocal of -4, that's -1/4. Reciprocal of -10, or what is this? This is -8. Reciprocal of -8, -1/8. Okay, so we know it's approaching 0 as we move in this direction. What about this way? Well, what's the this is -1/2 here, which would be -2. -1/4, -4. And so we're approaching infinity on this side. And so you can kind of use your logic. Remember that the key term here was they were asking us to sketch, right? So we're graphing it. Now we can check our answer. The nice thing is we can always check. So we can go and create a new document and a graph, and we can graph the original function, -3x plus 4, okay, which looks exactly like our f of x here. And then we can go ahead and add another one, and this time do 1 over -3x plus 4, and just make sure that we got it right. And it looks like we did. Okay, so we have our vertical asymptote there, and it's going through those points at -1 and 1 and going up to infinity, and then down to 0. Up to 0, down to -infinity. And so we have it right here. Let's go ahead and have you try one out. So go ahead and give this a shot. You're considering the function f of x equals 2x plus 1. And you're being asked to find the reciprocal function, the vertical asymptote equations, and of course to sketch your graph. and you can either make a table of values if you like that structure, or you can analyze the graph of f of x and take the reciprocal of those y values to find the new g of x y values and plot your graph that way. Both will be acceptable. When you're done, come back and we'll have the solution ready for you. See you soon. Okay, welcome back. Let's go through our solution. So here we're asked to graph f of x equals 2x plus 1. And that's going to be this line here. How would you have graphed it? Well, you have the y-intercept of 1 and a slope of 2. And that's enough information to graph your f of x line. Then what you should have done is created your reciprocal function equation. And so that's just g of x equals 1 over f of x, which was 2x plus 1. And use this to find your vertical asymptotes. How do you do that? You set this as cannot equal 0, and you solve for x. And so x cannot equal -1/2. That's your non-permissible, which means x equals -1/2 is your vertical asymptote. And you can see that here in green. X equals -1/2. And y equals 0 is, of course, the horizontal asymptote there in purple. All right. And then you graph the function. So you have your invariant points when y is equal to 1 and -1. And then you could have done your analysis of f of x and the reciprocals to plot some new points, and you end up with your graph there. Okay, that's going to be it for this video. In the next video, we're going to be graphing quadratic functions. Stay tuned. See you then. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end, and over here, you will find the next video in this unit. Keep learning, everybody. Take care.